So in the last few months, we spent building quite a lot of AI initiatives, AI agents for different organizations in different verticals. And from that, we learned a lot, we gained a lot of experience. And in this video, I'm going to showcase you basically a whole roadmap of building AI solutions and agents. What is basically true, what is the mainstream YouTube public not telling you. And I'm also going to showcase you what you should avoid when building AI solutions and what is the exact process that you should follow when building and implementing AI in your workflow inside of your business operations, right? So I think the best way to start is literally go from the start. This video is going to be like a one-on-one basic roadmap of the AI development, AI agent development, whatever you want to call it. But basically, it's literally I'm going to explain in most the simplest terms what AI agents are, what AI solutions are, what are the biggest misconceptions, and so on and so forth, right? So let's go straight into it. Now, the first point is the AI agent is a system that basically what is the AI agent? Agent is basically a system that perceives the environment through sensors, processes the information, and acts upon the environment. What basically that means is that AI is the autonomous system that understands the context and basically by understanding the context, okay, the user query, user input, it decides, it thinks, and uses its tools in a correct order, in a correct way to produce the correct output, aka the final output, right? Now, basically, in short lines, these are the steps that the AI agent normally takes. It's like perceives the environment, processes the information, acts to achieve the goals, and of course learns from their experience and tries to iterate their process to really provide you with the final output that you desire to, right? Now, the core tools or say core components of AI agent, what are the core components that basically assemble the AI agent, is the LLM, which basically acts as a brain, right? But basically, the processes the inputs, understands the context, generates the responses, and so on and so forth. The memory, which is basically stores the context, passes the interactions, uses the data, and learns from the information. And of course, the tools, which basically act as internal functions of the agent, which are like extended capabilities. Meaning, imagine like a tool that AI agent has in his toolbox, and if he basically perceives it, if he thinks that this is the tool that needs to be used at a specific time, place to achieve the final output, the AI agent will use it, and that's basically it. Imagine it literally, let's say, like an API call, get request, post request, whatever it is, right? Now, these are the quick picture of the overall macro schema of the AI agent, right? The user input AI agent and all of his core components. Now, let's break down the AI agent literally step by step. Now, the first point is reasoning frameworks. Now, there's multiple reasoning frameworks. I'm not going to go too much in depth because I'm going to bore you to the death regarding that. But basically, the important part, which I'm going to go in a second, is that AI agent thinks for themselves, meaning they think, they make decisions, and they solve problems by themselves, right? Basically, if you give him the output, if you give him the input, he'll break it down in a simple way. He'll plan the steps and he'll generate responses. Now, let's say when we were building an SQL agent, which is basically text to SQL agent for like one financial company, we are basically had like our data warehouse as a database, and we had multiple knowledge-based documents next to it as a tool connected to the AI agent. And when a user inputted a specific request, the SQL agent had to interpret that user text request, turn it into the SQL query, use specific syntax, meaning because we had a big query warehouse, he had to use specific syntax that is only used on big query warehouses. He had to run, he had to utilize tool BigQuery data warehouse to run the SQL syntax. He had to check if that's correct. He had to check if he's looking at the right table, if he's looking at the right attributes, right columns, and so on and so forth. Basically, he had to analyze the whole warehouse, whole project to understand, okay, if this guy is asking me to show me the financial report from the previous month, I need to first understand, okay, what table I'm looking for, what is the name of the column that I'm looking for, what is the date column, and so on and so forth, right? And he had to run the query. If it didn't work, he had to run it again, basically tweak the query and so on and so forth. As you can see, basically it act and literally and made the decision as a human being, right? Now, there's four types of different reasoning frameworks, meaning the top four big ones. But let's say the chain of thought, basically the AI explains its thinking step by step before giving you an answer, right? Then there's a tree of thoughts. Basically, instead of single chain, the AI explores multiple possible solutions like tree. React, which is basically the ones that are the most popular, and you're probably already using them. Basically, user input, the agent that receives a question, a command. Reasoning basically understands what it needs to do, what tools needs to utilize. Action it utilizes based on the specific plan that it created themselves. Observation, basically it reviews the tool's responses, basically understands, okay, in the mid of the execution, he understands, okay, am I on the right track? Is this the correct way? If it's not, he fixes it, and so on and so forth. Iteration, basically if there's some type of error, like in the previous SQL example that I gave you, if it's an error, he needs to basically iterate on its own, he needs to figure it out. And the final one is basically format the final responses, right? And as you're able to see, he literally goes in multiple ways. That's hence the reason why it's called reasoning plus acting. The fourth is basically self-reflection, which is basically in combination similar as React, which basically looks for mistakes, answers, basically looks for errors and tries to fix it himself. In short lines, the reasoning frameworks, imagine like the React, like this one, is literally the 1, 2, and the 4 all in combined in React, right? Imagine it like that. Now, the reasoning framework that you're going to choose, I'm not going to go too much about it because 99% of the agents AI solutions are just going to be built on React, again, reasoning plus acting framework, right? Right, but it's important to know that you need to understand what is the complexity of the task that you want him to do, the agent purpose, and of course the framework you're using. Now, how to decide? You can just check it out. If your agent needs the tools, use React. I'll just straight up recommend you just use React. Don't literally look up anything else. You don't need because React is literally all in one. Is a solution for, let's say, all in one. Now, the second thing is the memory, which is basically how agent and AI stores, recalls, and uses past information. AKA, the big problem that a lot of LLMs and a lot of agents have is the context limit, which is basically a lot of them, as you probably saw if you are into this, are just have a big limit, a bug. I won't say it's a bug, but it's just not done in a very well manner yet. But you can hit a token limit very, very fast in majority of the LLM providers, like Claude, GPT, and so on and so forth, right? Now, but there's quite a few fixes regarding that. There's few memories, like a few different ways that memory is stored and basically perceived. There's a short-term memory, which is basically stores the context from a conversation or task. Imagine if you're utilizing GPT on your left side, you have like a short-term memory, like a session-based. Basically, it's stores all of that specific previous conversations from that specific session, right? There is a few cons here because it stores, it's limited in the size that it can store, right? Because if you have, let's say, longer outputs, you will probably see in the GPTs or anything else, it will limit that. But also important here in the short-term memory case session-based is that it maintains the context with a single session, right? And if the session is deleted, all the memory gets lost, right? And basically, that's basically how it works. Now, as I said, implementation forgets the real parts of the long interactions, meaning if the context window is exceeded, right, it will basically remove that. It will not remember that excessive memory again past accession, right? If it passes the specific limit. Now there is another one, longer term memory. Now this is basically the stores data across multiple interactions, permanent beyond a single session for personalization. Now remember, let's say in the previous example, let's say you have like a GPT and you have multiple chats stored, and let's say in one chat, and let's say for an example you delete that chat, that's gone, right? You're not gonna get that back. But imagine now that you have a longer term memory that even if you delete that chat, it will still remember it, right? But basically what that means is basically storing the data all across, right? It uses to remember the facts, user preferences, and past interactions. And how it works is basically implementing a vector database, aka external storage, right? Instead of relying on LLM's memory, AI agent's memory, it basically utilizes a vector database, which basically stores all of the previous information for past conversations from your side, from the LLM side. It basically embeds that information, structured data, inside of the vector database. And basically, it retrieves by understanding your question, by your query, and it goes inside of the database, a vector database, retrieves it, performs a similarity search, and retrieves a specific part that thinks it's relevant. Now, the cons are that it's not perfect, right? It might recall some stuff that just are off. You probably saw it if you're utilizing GPT. If you have like a long thread of conversation in the GPT session, and you try to ask him a specific part that you ask him way before the start, he might just hallucinate and just think something else. He might just provide something that he thinks that he said, because he just doesn't remember it, right? And he might just say something that's like completely irrelevant, or he just like somehow resembles a little bit, but it's not really what you asked, right? So that's one con. Basically, it's not really 100% consistent. It's not perfect. The second point is storage cost growth, because it's storing literally utilizing the third-party database, aka the vector database. Larger and larger the context is, larger and larger your memory context is beyond in that specific. Basically, larger your conversation is, you can imagine it in that way, the more cost it is, because it requires larger database, more indexing, embedding, and so on and so forth. Now, there is a third option, which is basically hybrid memory, which are the most popular, which majority of the providers are utilizing, like Perplexity, GPT, etc. Other AI agents. This is basically utilizing both mix of short-term and longer-term memory, right? Best of the both worlds. Basically, utilizes the session-based that you remember the short-term memory, so it's more accurate, and utilizes also the longer-term memory, so it provides the overall context of the whole part that you want to achieve. And that's basically how it works, right? Now, are there any pros and cons here? Now, of course, the pros and cons are here. Sometimes it's unreliable, sometimes it still forgets. It gets slow over time because it has to remain the context. That's basically what I'm trying to say here, latency issues. You probably see it if you're utilizing GPT or Claude and you have like a long list of conversation in that specific session. It'll just lag a little bit, or it will be very, very slow. But I think the speed that AI and LLMs are just going, that's going to be fixed quite very soon, especially due to the cost of LLMs going very, very down on the longer term period. So that's basically it. Now, the third point, the tools. The tools are external functions that AI agent uses to extend its capabilities beyond just language processing. Now, imagine that AI has hands, that has a toolbox that it can utilize to provide specific tasks to achieve the overall objective. Basically, imagine the user asks, book me a call, schedule me a meeting with XYZ prospect or XYZ person, and in the toolbox that AI agent has is a calendar API for, let's say, get request for scheduling an event in the Google Calendar. AI will, in his reasoning, when he basically concepts and thinks what tools needs to utilize, and when he checks his toolbox, he will be like, oh, I have this specific toolbox, get request, calendar, I will utilize it, and he will perform that specific get post API call in Google Calendar, and it will book you and schedule an event for that specific person, right? That's basically how it works, in a more simplest way, how can I explain it. Second point, the AI agents versus workloads. Now, this is the big one, which majority of the people are just, I don't know why, but they think they're building AI agents, but they're simply not. And this is a very, very important point, because AI agents on a overall macro level, everybody thinks so they are the solution for everything, but they're not. I can tell you for a fact, if you're trying to push AI agents in every single thing, it's simply not gonna work, because they are not made to be pushed fully to production yet. Down the line, maybe, yes, but I haven't met a person, a CTO, a technical director, a developer, an engineer, a business, a CEO person who wants fully to be reliant on AI agent, especially in high compliant, high sensitive environments, which majority of people are, right? And here is basically what I'm trying to say, that majority of people are thinking they need AI agent, but they forget the scalability and consistency. Now, let me basically rephrase what AI agent is. AI agent is an autonomous system that perceives the environment, processes the information, and acts to achieve a specific outcome, right? It can learn from his previous experience, and so on and so forth. The best example I can give you, as I said above, is the SQL agent. Basically, it takes the user input from the text, it generates the SQL query, runs the SQL query in the data warehouse or any specific SQL database, runs it. But to run it, he needs to understand the database, he needs to understand the other tables, he needs to understand the attributes. Basically, he thinks what he needs to do. He doesn't just generate one syntax, he basically generates multiple SQL queries to understand what he needs to do. He generates, basically, in short lines, the best way to explain this is he generates himself a plan. Okay, I need to do this. He executes that plan. If there is an error, he repeats it to fix it, and when he feels like that he achieved the full objective, he will provide with a final response. Right? Basically, it's full autonomous. Imagine like having a cooking robot, and you put him in a kitchen, and you give him like a recipe, which is your user input. And for tools, he has like knives, ingredients, and so on and so forth. And you basically give him, let's say, okay, cook me, I don't know, a specific meal. AI will be like, okay, I need to use the knife in this step. I need to utilize this ingredient here. I need to utilize this. Basically, he will act on its own, right? Now, workflows and chains. Now, chains, what I'm saying is, why am I saying chains is because Langchain, the agentic LLM framework, aka orchestration framework, whatever you want to call it, uses that acronym. But workflows is a predefined sequence of tasks or steps that follow a set of rules for a specific business process goal. Basically, it's a static, meaning they follow a fixed structure. Now, this is a big thing because majority of people thinking they're building this, AI agents, but in short lines, they're building this. Or more importantly, they think they need this, AI agents, but in short lines, they just need this, right? You get me? Now, the best way to explain workflows and chains is literally data flow. Data literally flows from one process to the another, to the another, to the another, and so on and so forth, right? Imagine, let's say, the best way to explain it also is, let's say, process one. When a process one output is the input for the process two. As you can see here, the data flow is a sequential thing, and it's a fixed structure. Now, why this is good? This is very good because it's very easy to debug. It's very easy to see where the root cause of the problem is. It's very easy to build because you have more control and more flexibility to it, right? And more importantly, it's scalable and reliable, plus consistent, right? Now, now here I'm to the point where you should utilize chains, like workflows, and when should you utilize agents. Utilize workflows, which is going to be 90% of the cases in your business. Remember what I said. It's going to be 90% of the cases more sense to utilize chains, like workflows, than AI agents, right? Basically, utilize workflows when you need a straightforward sequence of operations without the need for real-time decision making. As you can see here, the above example, right? It would be very, very hard to build an SQL agent in this type of environment. It would be very, very hard, right? Utilize also chains when the task can be clearly defined with a set of inputs and expected outputs. The best way to do that is to literally map it out on the flowchart. Literally, if you want to build an AI agent or whatever it is, literally you open up your Lucid Spark Miro and just map it out, and you can see the whole data flow. Literally the chart will tell you if you're gonna see like something like this, that's gonna pretty much tell you that you need to implement workflows and chains, right? Literally like that. Now, when should you utilize agents is when the task requires adaptability and the ability to respond to changing conditions or user inputs. Basically, you want to leverage the reasoning capabilities of the LLM. I'm gonna literally bold this. LLMs to determine the best course of action dynamically. The best way to do that in your business is to ask yourself, does here need to be a human intervention, or does here need to be a human decision-making process, right? That's how we go about when we try to do a business analysis and we see, okay, where there is a chance to implement AI, right? If there's a specific chance of utilizing AI in this kind of case, that's going to be the reason, basically reasoning capabilities. That's the only reason why you want to implement AI agent, nothing else, right? Why I said, and how, if I go back on the previous example, the SQL agent, if I tell him, give me the financial reports from the previous month, and he will need to go first into the data warehouse, he will need to check the tables. As you can see here, there's a lot of stuff he needs to do. and it's going to be very hard for me to build it in a sequential order, because it's not in a sequential order. It's simply not. I cannot be like, okay, go in a SQL agent, go execute the query, okay, go now provide me the final output. Yeah, but what if the query is wrong? What if the table is wrong, etc., right? What if I have like 10,000 tables inside of the data warehouse? Like, I cannot build it in a sequential order. That's why I need an SQL agent, right? You get the point. Now, what should you do? In majority of your cases, the chains are just going to be the best thing to do, because they're going to be reliable, scalable, and consistent. What we recommend is to build hybrid. Use agents when the agents need to leverage their reasoning capabilities, like decision-making patterns, and utilize chains where you basically have like a sequential order, straightforward sequence. The best way. Also remember, think, when I say sequential workflows chains, just because you utilize, let's say here in this process, LLM, that doesn't make it an AI agent, right? I just want to clarify that. Just because you utilize, that's still a chain. Even if I have like LLM processes in here and GPT processes in here, it's still a workflow empowered with AI. That's it, right? You get it. So I hope I explained that and beaten that narrative for most people. Now, the third point. Now, there are many AI agents that depend on the basically types of agents. I'm just going to go over this very quickly because it's like a gray area. You have, let's say, like a simple reflex agents, which basically, if this happens, do that. You have model-based agents, understand the world and the size. Goal-based agents, utility-based agents, learning agents, which is basically learns from the past interactions, improves it. Similar like your GPT, when you have a conversation with it improves it, and it knows how to answer in the other chats, other sessions, and basically understand your whole personality and tries to be very, very personalized to you. That's one of the reasons why the AI GPT has the settings to remember your memory, right? So you don't need to keep repeating itself. Learning agents, multi-agent system, which is basically multiple agents work together instead of one AI. Many agents collaborate to each other to solve one complex problems, right? Imagine like a self-driving cars communicate to avoid accidents, swarm robots, and so on and so forth, right? Utility, let me just go back quickly. This is just like a simple agent, basically it's things like that. But the most important part that you should hear just to understand is, let's say, the learning agents, the multi-agent systems, right? You can literally stop this video and you also can read this through, right? Because they're pretty much, it's a bit of a gray area if I'm being honest with you, but it's worth to mention it. Now, AI agent architectures. We have two different types of AI agent architecture. We have a single agent and we have multi-agents. Single agents is when you need to utilize agents is basically it has one specific specialization. That's what you need to do if you're just utilizing one AI agent. Meaning, let's say you have an AI agent for SQL, literally his specialization, his role is an SQL agent, SQL assistant. That's one way to literally determine when to utilize single agents, aka multi-agents. If there is a scenario where you cannot really tell that specific agent that he's like that's specializing in one specific area, I think then you need to think in terms of multi-agents. So basically, stop utilizing single agents when there's too many tools to connect it to each other, because it's going to hallucinate, it's going to make poor decisions. The context will grow way too quicker, it will just simply forget. And there is no specialization, right? So this is basically here, you're now here. Let's say you need to utilize multi-agents. Multi-agents basically break a more complex query, more complex user input into much more smaller queries, right? Basically, multiple agents together act together to be able to solve a huge problem, right? Why this is good? First of all, is modularity, because it's easier to debug, it's easier to develop, it's easier to test, it's more consistent, it's more reliable, right? The fifth point, you also have more specialization, because each agent is specialized in one specific area. You don't have like one agent that literally does the SQL part, it does the Python part, it does the report generation part. No, you have, let's say, SQL agent. Literally, the only goal from him is to provide me with the final output from our SQL database. That's it. Nothing else, right? And the one more important part, you have the control, right? You are able to really have control over the whole system. Now, under the multi-agent systems, you have multiple different architectures. The supervisor, which is basically each agent communicates with the single supervisor. Imagine, let's say, one supervisor right here, and he communicates with every single agent, agent 1, agent 2, agent 3, right? And every single input, let's say supervisor provides the input to the agent 1, and the agent 1 provides the final answer back to the supervisor, right? And the user interacts only with the supervisor. That's the important thing. Now, the pros and cons are here the specialization. Literally every single agent has his specific specialization, and same applies for the supervisor, right? It's great for, let's say, multi-agentic complex systems while keeping like modularity and control as well, right? Then you have, let's say, supervisory tools, which are basically, rather than having agents connected to the supervisor, you have tools connected to each other. Where, let's say, for an example, you have, rather than an SQL agent here, you just have, let's say, I don't know, you're wrapped in the tool type, right? Now, here is the good thing that's or let's say one of the examples that's rather than having like an SQL agent, you would just have like a database connected to it for executing a specific query. That's it, right? That's good, but problem is that there is no reasoning or decision making here. Yes, it is very easy to implement. That's why a lot of people do it, but simply it's not reliable, I would say so, at least from our experience. Swarm. Swarm is a type of multi-agent architecture where the agents dynamically hand off control to one another. Now, I have simply seen this pop up a lot, but I haven't seen it in the production, honestly. The only part that I've seen it in production where there's like, let's say, only two agents together. But even then, I see a lot of inconsistencies and a lot of unreliability happen when there is a swarm involved, right? But basically how it works is literally, it doesn't go, there is no supervisor agent. Every single interaction is, and the whole data flow is passed around agent 1, agent 2. Basically, all agents collaborate with each other. The problem here is very hard to debug and maintain, because if the error happens, you're not going to see or know when did it happen, why did it happen. You don't really have a control over it, right? And I would preferably for now on, I wouldn't advise to utilize Swarm. At least I haven't seen it in production work anywhere, right? Anywhere. Now, there's also much more others like network, hierarchical, custom multi-agent systems, and that's basically it, right? In short lines, use multi-agent systems when you need scalability, flexibility, and fault tolerance, and avoid multi-agent systems when you literally have like a simple rule-based systems, right? Now, third point, prompting. Prompting is a big thing. If you're able to build AI solutions, AI agents, or if you're just playing around with LLMs, you're going to probably know that prompting is literally 70% that you're going to spend time with it. Now, of course, there's going to be other parts, but prompt is probably one of the areas where a lot of people are either underestimating it, that it's important, or they're just overestimating it. Like, so it's like a gray area, I would say so. But one thing that I want to debug with the prompt is that a lot of people just go literally on the web, they find one prompt and just literally copy it, paste it in the agent, and they think it's going to work. No, it's not going to work like that. The best way about prompting is literally an R&D approach. You start small, you test, you add, you test again, and until you generate the output that you're fine with it, that it will know it work, right? Now, the best way, I think the way how I would showcase you what is the best prompt structure is literally, no, I'm not going to do that. Let me see if I can find it. But yeah, it's here basically. Now, before going to prompt framework that you need to utilize, the best way is simplicity and specificity. AI allows it. Break down the complex requests. You use formatting for better outputs. Don't expect to format it nice from the get-go, meaning don't expect AI to do anything that you didn't tell him, right? Because if you don't you don't tell him in a very specific manner what he needs to do, he will probably hallucinate, right? Don't assume, because AI is a statistical predictive model, right? LLMs, right? He basically predicts every single thing from your word, letter, and so on and so forth, right? So don't literally assume that he will know. Now, the template structure that you need to utilize. I think the best way I'm going to showcase it is on the picture, because on the document it looks a bit weird, but let me showcase it on the picture. This is the only prompts framework that you need to utilize for everything, literally. Down below, I'm going to also link one document which is talking only about prompt engineering, and there is in that document it's also over 40 more prompt examples that you can literally take it and literally tweak it for your specific situation, and it will work. But in this case, this is the prompt framework that will work every time, and we use it all the time. And how to use it, as I said, is basically R&D approach. You start small and you keep adding. But this is the overall prompt structure. The first point, you need to add a role. You need to tell him you are the AI orchestration agent. You basically give him a specialization. You give him a role. If you cannot give him, you give him a task, right? Let's say if you cannot tell him you are the best PDF formatter agent, you just give him, or you can tell him, you can literally just turn that into a role. But if you cannot, you can just literally, you are the best at formatting XYZ. You are best at this XYZ task, like that. You basically give him a specification, a specialization in a specific area. The second thing, objective and tasks. You give him an objective. What is the end goal you want to achieve? As you can see here, right? Third, the context and variables. You here input all the context, and let's say in our example, here is the orchestration agent. But you basically tell him, let's say, the previous conversation, the current query, everything, right? Any type of knowledge base, whatever it is, you give him here. The fourth step, you analyze, you give him literally basically the steps that he needs to take, right? How he needs to think, the decision-making process of the AI agent. The fifth, available agents and tools. You basically need to tell him, okay, what is in his toolbox? Is the SQL agent, what tool he needs to utilize, when he needs to utilize, and so on and so forth. The sixth, decision rules. When he needs to utilize specific tools, what he needs to do, what are the important parts that he needs to not do, X, Y, Z, and basically the whole decision-making process. This is very similar to the step 4, but in the step 4 is basically just a repeatable, straightforward approach. Basically what he needs to do on the macro level. As you can see here, analyze the query, match the query to the correct agent, if multiple steps are needed, blah, 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 blah. And here in the step 6, decision rules, basically use tool, generate tweets when the query, blah, blah, blah. Utilize SQL agent when it needs to do this. Utilize RAG agent when the user query is about this, and so on and so forth, right? It's more granular. And the 7, you provide him with the example, right? In our case, we want him to provide me with a JSON example, like this. I literally provide him, look, I want you to give me a similar like this. And it works 99% of the time, right? Literally. I kid you not, it works. And another point to mention, AI, LLMs love JSON. So utilize it as much as possible, because that's how you will achieve consistency and reliability. Because JSON is a structured syntax. It cannot be more structured than JSON, right? And AI simply loves it, right? Now, I think that we covered the AI agents prompting the most, but I'm gonna link down below also the document, which I can share here as well. Give me a second. But here is also the document, which goes really in depth about prompt engineering, literally the misconceptions. The one big misconception is that the prompts have to be big, long, and complicated. Not true. If you get the final response and the final output that you desire and you really like it, you don't need to keep adding stuff, right? It doesn't need to be like that. The thing that AI needs is context, literally that. The prompt framework that I just showcased you, the prompts library, as you can see here, literally the already made prompts that you can literally utilize it and input and tweak it to your specific situation. The AI agent prompts that we utilize when we are building our AI solutions and initiatives for companies and internal solutions as well. So basically, if you want this document, you can literally just go down below. So AI frameworks. Now here are the multiple frameworks and tools and software libraries that you need to utilize if you're trying to build AI agents and solutions. The first one is Langchain, which is basically like an orchestration. Now it's more orchestration, but it's more so like an agentic. In the past was like, let's say, like an agentic LLM framework builder. But basically it integrates with multiple LLMs, vector databases, APIs. It has pre-built agent types like React, majority of the cases, strong ecosystems, basically tools, memory and retrieval, utilized by the pros, like the big players like Replit, Klarna, etc. Right? Problem with Langchain, sometimes it overcomplicates specific syntax. Let's say if you're trying to, sometimes if you understand Python, it can be much more simpler, but the Langchain for some reason just complicates it a little bit. You could say so it's a little bit more complicated to learn, because just for some reason Langchain just likes to complicate things. The second thing which I absolutely dislike about Langchain and LangGraph and others is bad documentation. Thankfully, they have a good YouTube channel, but they don't post that much frequent. But their documentation over on the web is simply garbage. You don't really know what's like still up to date and what's outdated, so it's very hard to do. The other point is high latency, because you're basically utilizing like a in between provider, like a bridge in between the LLM and between your backend operations and of course LLM calls. Sometimes the latency is very long, okay, high, right? So, but basically that's a big problem with other majority providers, right, as well. The second one is Llama Index, which is formerly GPT Index, designed for integrating with LLMs with the external data sources, mainly RAG, efficient indexing and retrieval of large documentations, supports basically the main vector databases as Pinecone, Chrome, Viviat, Face, and so on and so forth, mainly made for, let's say, enterprise RAG applications. Requires additional setup for indexing and storage. But to be honest, it's in regards to the console, so there is no as many features, capabilities, tools as Langchain, because Langchain has a lot of stuff, right? But overall, it's very good, especially if you're trying to build something with RAG. Autogen multi-agent orchestration system supports memory, good for research and code generation. Heavy setup complex, it's a bit complicated to set up, if I'm being honest. And as I said, longer processing times due to latency. Crew AI role-based multi-agents is the one problem with him with the Crew AI. It's you don't really have a control over them as much as you want to have it. Lightweight, you can say so. It's easier to set it up as Langchain. It's very good for business process automations. As I said, the cons are that it's quite limited in its capabilities and features, fewer integrations, and it's less supported of, let's say, RAG retrieval methods, I would say so. But overall, I think on the top here, the Langchain still stands still. We like to use personally here Pydantic a lot, or we just build it custom from the ground up without any type of LLM AI frameworks. But if I could summarize it, Pydantic, Langchain, LangGraph, and direct custom build. Basically, when I say direct custom build, I mean without any type of AI frameworks involved with it, right? Now the fourth is other tools and technologies. Let's say the vector databases, Pinecone, which is basically the difference here is that it's a vector database stored cloud native, highly scalable. The cons are it's more expensive. It has actually large data in it. Expensive at scale, I would say so. Less flexible and less flexible customization than Viviat and Face. Viviat, open source with self-hosting, amazing. A bit more complex to set it up than Pinecone. Pinecone is, I forgot to mention, but it's super easy to set it up. Like literally super easy. Great documentation. Everything is super good. We are utilizing here also for our internal stuff. Chrome IDB, best for Langchain. Lightweight to utilize it. Good for small scale RAG applications. Not very good, as I would say so, for like high scale production workloads. And limited for enterprise adoption compared to the Pinecone, right? Face, which is basically from Facebook, blazing fast, super fast, especially for large scale search. Great for self-hosting, supports GPU acceleration if that means to you anything, but I won't say that's relevant to anybody here. Requires a significant engineering effort to deploy, and of course it's not cloud native. Now the only one that's cloud native here is the Pinecone, which I'm probably the biggest. I would say I would recommend Pinecone to anyone. The other one that I would recommend is Chrome IDB if you're just starting out to build something at a smaller scale, right? Those are the other two. Now, no-code tools, Cursor, the AI code editor, Lovable AI code editor as well, Replit, same cloud-based code editor. I'm not sure if you can call the Lovable and Replit also the cloud editor, but let's say so. More so Lovable and Replit, and of course, I shouldn't forget one, but basically also Vercel V0. Those are more for, let's say, front-end applications, I would say. I love building, and our engineers are also utilizing those tools for front-end, even though majority of us are just utilizing Cursor because it's just simply the best, right? Flowwise is good for no-code, low-code AI agent builder. Basically has, let's say, provides with the UI presentation of how you're building AI agents. Rather than building it straight up in the code, in the Cursor, it basically showcases you and visualizes you the whole orchestrations of AI agent visually, and you can literally just build it in there, right? And it's local as well. You're able to do that. And basically, suppose it's more so used by Langchain. It's built upon the on top of the Langchain. Same applies for N8, which is basically like a workflow automation builder built on top of Langchain as well. And it's simply amazing, right? Both of them parts are very, very good for building no-code, low-code, small-scale applications before you move totally to code. Now, here's the fifth process, which is the process of building AI agents, which is basically conducting the stakeholder frameworks. Now, these are the whole process of going about building the AI agent. I'm just going to go over it very quickly because we are very quite deep in this video, but basically the first step is define the AI agent's purpose and requirements. The best way is to interview the stakeholders, executives, to map out the business operations, BPN flowchart. If you don't know what it is, just Google it. If basically you map out the whole business operations, you understand, okay, where there are red zones, how is the data moving. The red zones should be the places where it's a very important operation part. It requires a human intervention, it requires human decision-making processes, and that's a process that you can utilize AI solutions, AI agents, LLMs in your workflow, right? That's how you conduct a business analysis in literally as a scientist. You also understand the qualitative and quantitative metrics, how they measure performance and success. And that's how you do it. You then map out the LLM architecture. Basically, once you agree and you see, okay, we can utilize the LLM and what solutions we can build, AI agents we can build, you should map it out in the side with a Lucid or Miro. Basically, you just open your Lucid or Miro and just map it out the whole process of how AI agents should function. You basically, how we call it here is actually like a LLM AI architecture. You can also call it like a data flow, which you basically see how data flows from each process to the another. And what will that do? It will basically help you gain clarity what techniques and tools to use, when you need to utilize chains and workflows, and when you need to utilize agents. You will understand where the potential bottlenecks can happen. You will determine, literally, as I already said, I think, what tools and technologies you need to utilize. You will also need to, it will give you a clarity where what multi-agent architecture you will need to utilize, if that's the case, like a multi-agent system, what type of memory implementation you will need, and so on and so forth, right? And as I said, the best way to start it is to map it out in a sequential order, more in modular parts. So you're able to see how data flows throughout the whole system, so it's much more easier to debug and build. Don't just build AI agent and just expect it to work. It won't work. You won't have flexibility, you won't have control over it, and so on and so forth, right? That's basically the case. Basically, you map it out the whole system. Then you utilize and choose the correct tools and tech stack. You optimize the workflow and decision-making processes. Basically, you already go into the building mode. You test, debug, you see where the issues are happening. Are there long, high latency issues, unnecessary specific computations, and API calls? Are you needing any type of LLM frameworks at all, as the above, or not? You basically improve it, iterate it. And yeah, you implement specific tracking stuff as well. Let's say like Langchain is very good for tracking the overall, for tracking and debugging the whole AI agent, multi-agent systems. And then you simply deploy it on the cloud or on-prem, right? Whatever you decide to. That either be render, VPN, railway, whatever it is, which you are mostly utilizing, or also, let's say, AVS, Azure, or GCP, whatever it is, right? Or if you're utilizing on like the local no-code builders like N8N, Flowwise. I'm not sure if Flowwise supports it, but N8N, you can literally have it there as well, right? Which I think they are already on cloud, but you can also host it yourself, right? Now, here are some of the AI-proven solutions that we already built and we are working. Let's say Smart Spend Analytics automatically ingests the data from purchase ledger, vendor masters, and other financial systems, categorizes the spend by supplier regions, and so on and so forth, generates real-time dashboards, cash flow efficiency and insights. Let's say AI reviews payment terms, historical invoice patterns, flags yearly payment discounts, duplicate vendors or late payment trends, provides suggestions or to optimize workflow capacity, again, working capital, pardon. AI-powered business intelligence. Basically, the analysts are able to communicate with the data itself, extract actionable insights, provide and see automatically generated analytical dashboards. AI financial agent, which basically automates the analyze the books, the financials, the cash flow, analyze the whole financial systems of the company, provides you with the insights where the potential bottlenecks and anomalies can happen, and provides you with the whole plan to stay profitable and achieve your top-tier objectives. The custom content AI generator provides you with the top high-quality content topics, ideas, and generates you multiple different content formats. So you're able to literally just post it based on your previous top high-quality performing content pieces that you had. Custom AI, which basically just analyzes your ads manager, competitors ads manager, and provide you with the same scripts. It basically generates you the new ideas, analyzes also the market, to conduct the market research, and based on all of that context, provides you with the new ideas for ad creatives, generates you the new scripts, and you're able to literally push as much marketing assets as much as ad creatives to the ads manager. Also provides you with the analysis of the ads manager, which tells you, okay, what you did wrong, what you could do better, and also provides you with the specific forecast methods, let's say, based because it's made from your decision-making patterns and your knowledge. It provides you, let's say, scores your creative ad ideas from 1 to 10, how likely are they to succeed, like this. AI enhanced CRM automation, which basically you're able to move deals, add notes, log specific objects inside the CRM, literally by typing inside of the chat interface in Slack. Document and anomaly detection basically scans the business documentations and looks for specific compliances, risk, and financial red flags. Insurance agents, which basically able to dissect the image, the claim, and automatically provide you with the approx cost by how much it will be this to fix, which assesses it from the image, which basically saves a lot of insurance's time. Then there is, let's say, AI-based churn prediction. This is more so like machine learning model, I would say so. I will ignore that. AI-powered inventory and stock management basically understands your whole sales trends, sales forecasting data as well, tries you to predict and provides you insights at specific products, SKUs, when they are fast moving and they are not in stock. For the ones that are, let's say, cluttering the stock, but they're like slow moving, okay, they're not selling as much. So you're basically telling you what you should put on the sale and what should you order and when should you do that, right? And the last one, let's say, AI driven dynamic pricing, which basically provides you with and monitors your whole world view prices on the whole, basically provide you with the whole data of the different prices for the specific materials in the literally on the whole globe, and tells you, okay, this is now in this area is very cheap, you should order this, and you're able to literally get the specific materials at a lesser cost than if you literally just bought it at a specific area all the time, right? And that's how you're able to literally save on costs if you're, let's say, a manufacturing company and so on and so forth, right? But these are just some of the use cases, but there's so many of them. But basically, this is a quick video. I mean, it's not quick, it's like 45-minute long video, but if you enjoyed it, we are a custom AI solution, or we are basically an AI agency. If you're looking to build AI solutions, data solutions, or you want to gain an edge by implementing AI and data initiatives in your business operations, you can book a call with our exploration team and we're glad to help you.